Topographic Map Skills. So what exactly is a topographic map? Well, here's one. You see, a topographic map is different from a regular map in that it doesn't just show the outline of a landmass, but rather it shows the three-dimensional shape of a landmass. So you can visualize things like hills and valleys and cliffs, rivers, etc. This particular topographic map shows an island surrounded by the gray ocean. Each of these lines is called a contour line, and it shows the elevation of that particular spot on the island. So for example, if you were standing at point D on this map, you would be at an elevation of 200 feet above sea level. Why? Because point D is located on the 200-foot contour line. So what that means is we have an island here with the highest point right by that triangle, which is labeled 325. So today we're going to talk about some of the skills you need to have in analyzing a topographic map. And it really boils down to 6 basic questions that need to be answered. First, what is the map's contour interval? Second, what is the highest or lowest elevation shown on the map? Third, where is the steepest and flattest part of the map? Fourth, what direction is a stream or a river flowing? Fifth, what is the gradient of a particular slope? And sixth, what does this landform look like from the side? In other words, what does the profile view look like? So what I want to do is go through each of these questions and give you an example of how they can be answered. Let's start with the first question. What is a map's contour interval? Well, first off, I mentioned that these lines are called contour lines. So when we say contour interval, we mean how much is each line changing by. Let's look at a map. Now, in most maps, the contour interval will be labeled. For example, on this map, the contour interval is 10 feet, and it's labeled for you right there on the bottom. However, we are going to come across circumstances, like on this map, where we don't have a contour interval, and we're left to our own devices to figure out what it is. Now, this particular map has a handful of contour lines, and you'll notice that some of them are darker in color. Well, those are called index contours. We have a 50 index contour and a 100 index contour. And then we have some other lines that aren't quite as bold. And so we need to use this information to figure out how much the lines are increasing by. Well, if you do a little bit of math in your head, you would figure out that this line right here must be a 60 line, making this a 70, an 80, a 90. Now, that tells me that the interval of this map is 10, and I figured it out just by counting the number of lines between the 50 and the 100. You might have to do a little bit of trial and error, but eventually you'll be able to come up with the amount that each line is increasing by, also known as the contour interval. Next, how do we find the highest and lowest elevation on a map? Well, again, let's go back to that map we saw before. Now, this map is helpful because it actually has a symbol shown here with a triangle and a dot that shows you the actual highest elevation, in this case 533 feet. However, unfortunately, some maps don't give you that, like this one. This map of Rock Mountain is clearly the top of a peak shown at point X here, but we have to figure out what could the elevation of point X be. Well, in order to do this, you have to look at the surrounding contour lines. For example, I have this one labeled 1500. Now, by doing a little bit of math in my head, I can see that the interval on this map is 100. And what that means is that this next line would be at an elevation of 1600. Now, I can conclude that point X, because it's inside the 1600 line, has to be higher than 1600. But notice there's no 1700 line. So what that means is that point X is greater than 1600, but less than 1700. So if I were asked what the possible elevation of X is, any answer between 1600 and 1700 would be fine. But what if I were asked what's the highest possible elevation of point X? Well, that in mind, greater than 1600 but less than 1700 means that the highest possible elevation of X would be 1699. But what about lower points on a map? Well, if I look at this map, it seems to me that the lowest spot would be over here by this 800 contour line. And this is decreasing. This river here is flowing downhill. That means that this is a 700 line. And that means that the lowest part of the map is actually in this green area here. Now again, I know it's lower than 700, but because there's no 600 line, the green area has to be between 6 and 700. If I were asked what the lowest possible point shown on the map is, again, it would have to fit in that 700 to 600 range, making the lowest possible elevation 601. But how can we find the steeper or flatter parts of a map? Well, again, let's look at Rock Mountain. This is very easy to do. Wherever your contour lines are really close together, like right in this pink area, I know I have a very steep slope. And the reason that is because I have a big change in elevation, but over a short distance. And for that to happen, you have to have a very steep vertical slope. Now, the opposite is also true. If you want to find the flattest area, look for an area where the lines are far apart, like this green region. This would be our flattest slope. So the steeper slopes will be where the lines are close together, and the flatter ones where they're far apart. What about streams? You know, when you look at a stream on a map, it tends to just look like a black or a white line running in all different directions, and it's hard to tell which way it's flowing. So we have two rules that we're going to follow. Rule number one, streams always have to flow downhill, meaning from higher elevations to lower elevations. And of course, this is because of gravity. Let me give you an example. Take a look at this map. Now you see I have this stream, this white line running kind of in the center of the map. I don't know if it's traveling north towards the top of the map or south towards the bottom. But what I do see is that there's a 500-foot contour line here and a 400-foot index contour over here. Now, what that means is that the river has to be going from the higher point to the lower point, or in other words, it's flowing like this, towards the north. But we're also going to run into scenarios where we don't have labeled contours, and so we have to follow Rule 2, which is that streams always will flow opposite the bends found in contour lines. Here's what I mean. Look at this map. I have a stream flowing in the middle here, but I only have one contour line labeled, so I don't know where the higher and lower elevations are. So what I'm going to do is I'm going to look at the actual contour lines. If you look carefully, you'll notice that when they cross the stream, they make these almost like V shapes, these bends. Now these are a clue for you in terms of the stream flow direction. Our rule stated that the stream always flows opposite these bends. So if these bends are pointing to the top of the map, the stream is flowing to the bottom of the map. Or in other words, the stream is flowing to the south. What about gradient? Well, when we say gradient, gradient is a measure of how steep a slope is. It's a numerical measure, meaning we can actually calculate, is a slope very steep or is it very gradual? So let's look at another map here. And in order to calculate gradient, we need a formula. The formula is change in field value divided by distance. This can be found in the Earth Science reference tables. Now, in this case, field value refers to the elevation. So we want to know how much does the elevation change over a given distance. So let's say we want to find the gradient between points x and y. Well, I have to find the elevation of x and y. Now, point x is easy because it's on this line labeled 500. So x has an elevation of 500. Now, if you were to figure out the contour interval here, you would see that it's 20. And by doing a little bit of math here, you would see that point y has an elevation of 420. So I've got my changes in field value. It changes from 500 to 420. Now I need to know the distance for the bottom of the formula. Now to get the distance, we have to use the map scale. What you would do is you would take it and you would line it up with points x and y, like so. And I see that x and y are a distance of 2 miles away from each other. So, distance equals 2 miles. Now it's simply a matter of plugging these numbers into the formula. So the gradient's going to equal the change in the elevation, which would be 500 feet minus 420 feet, divided by the distance of 2 miles. You can simplify 80 feet divided by 2 miles, and you get an answer of 40 feet per mile. So what this means is that if you were to walk down this hill from X to Y, for every mile you traveled, you would be getting 40 feet lower. Finally, what about a profile? Now, a profile is simply a side view of a landscape, just like a profile photograph would be a side view of somebody's face. Let's say I wanted to draw a profile along line AB here, or figure out what this landscape looks like from the side. Now, in order to do this, we're going to eventually use a little graph like this, which will generally be given to you. We also need a piece of scrap paper. And so what we can do is line our scrap paper up with the line that we're drawing a profile along. And we're going to mark anywhere a contour line crosses our scrap paper, like so. Notice I did not mark the stream, just the contour lines. And I labeled each one with the elevation of that contour line. Now that I've done this, I can take my scrap paper and move it over to the bottom of my graph. And we're going to go ahead and plot points for each of these elevations. For example, here, 900, 880, 860, 840, 840, 860, 880, 900. And now all I need to do is connect these dots with a smooth curving line, and I've done it. This is a profile view of that valley. That white stream there, that would be flowing down at the bottom of this valley. And so that's some basic topographic map analysis. Thanks for watching.